In part 3 of section 12, we're going to be discussing a very special format of the quadratic equation called the vertex form. Standard form was what we started the section with, and that was the ax squared plus bx plus c format of the equation. And there are definitely uses for the standard form, but I mentioned before that the vertex is probably the most important point when looking at the graph of a quadratic function. So there has been a great deal invested in the vertex. So definition 12.2 is going to introduce what's called the vertex form of the quadratic function. So the vertex form is going to take the a, b, and c, and it's going to turn it into a, h, and k. So the a is going to be the same, but the h and the k will not be the same as b and c. They will be different values. Now, in order for this to work, you can see here f of x equals a times x minus h all squared plus k. This is going to be analogous to transformation form. When we talked about transformations, we talked about adding or subtracting a number from the x on the inside. That represents a horizontal shift. Plus k is going to cause your function to either shift up or down. So that's a vertical shift. And then a, as we discussed earlier, a has the ability to be able to tell us about opening up, opening down, but it also tells us if there's going to be a stretch or if there is going to be a shrink. So this is called vertex form, but you can also call it transformation form. The big deal with the vertex form is that the values of h and k represent the vertex for the graph of your quadratic function. H comma k does represent the vertex. So if you understand how to read vertex form, you get the vertex for free. Hence why we call it vertex form. So go ahead and take a look at example 12.2. It says, let f be a function from R to R. State the element of f that represents the vertex. Remember, the elements of a function are always ordered pair. So when it says element of f, it's talking about an ordered pair. That's what the elements are. And when you graph all of the ordered pair, that's when we get the curve, the parabola shape. So taking a look at part A, f of x equals, we have a parenthesis, x minus 1, close parenthesis, square, plus 2. So the idea here is that we want to be able to identify what is the a, what is the h, and what is the k. And if we can do that, then that means that we're in vertex form, and then we get the vertex for free because it's h comma k. Remember that there is an implied multiplier of 1 in front of that parenthesis. We can always do that with any algebraic statement. That means a is equal to 1. And then for h, you have to think about the transformation. So in transformations, we notice that the adding and subtracting for horizontal was what we call counterintuitive. It was opposite of what we would have expected. So when it says x minus 1, that actually shifts the graph to the right by 1. So that means h is a positive 1. Plus 2 at the end tells me that k would have to be equal to 2. So for the vertex, I'll abbreviate that with capital V. The vertex is going to be located at 1 comma 2. And it's that easy. If you can recognize the vertex form and you can pull out the h and the k, you get your vertex for free. And then the rest of the graph comes very easily. And we'll talk about the graphing more a little later in the section. Let's go on to part B. F of x is equal to x plus 3 squared plus 5. So again, in this situation, there is a multiplier of 1 implied at the beginning. So I would say a is 1, and then I want to move on to h. Now here we have x plus 3, which would indicate that I'm actually going to be shifting to the left by 3. So that means that h is negative 3. And then k will be positive 5 because of the plus 5 there at the end. Take a look at part C. On part C, we have an implied 1 with that negative, which means that there's a negative 1 multiplier there in front. That tells me that a is negative 1, h is going to be positive 2, and this time k is going to be negative 4 because we're subtracting 4. It's going to cause the whole graph to shift down by 4. So our vertex is then located at 2, negative 4. And then finally on part D, we have an a value of 2, we have an h value of negative 6, and we have a k value of negative 1. And our vertex would be located then at negative 6, negative 1.